Welcome to the Group 712 Software Architecture and Design team. We've got a lot to go over today, and there's four major categories that we're going to talk in a brief amount of time. First, we'll dive into the software demonstration itself, followed by discussion about design modifications. Then we'll go into elements of the team implementation, and finally discuss meeting the customer requirements. All right, let's go ahead and get started. So what you see here is the virtual machine image that we provided, the .ova. To get to this point, all you do is type in student for the username and student for the password, all in lowercase. Now that we're here, let's double click on home. Then we'll click on the 712 architectural team folder. We need to start the back end, so we're going to right click there, open in the terminal, and then we just need to do a simple Gradle command, which is Gradle boot, capital RUN. Wait for that Gradle daemon to get up to about 75%. And the only other thing we got to do is just right click on this Osmosis UI, open in another terminal, and then just do npm start. What's nice here is Firefox will go ahead and launch, and this will give you an idea of our application environment. You'll notice immediately there's a lot of improvements here. Here we've got a GUI interface. We've also got this really nice drag and drop feature that allows us to be able to go through. If we dive into the team design folder, we can load a scenario file directly. So that's a huge improvement, because when we had our individual implementations, we had to do all that in the terminal. The scenario file that we chose was the Smart 6, because that ends up showing off the smart algorithm that our team developed. Just drag and drop that in. The UI gives you reinforcement that it did load, and then you just press Let's Start. And you'll notice immediately you've got a nice summary screen here, and that's going to give you an idea of a lot of different statistics, like the total size of the lawn, mowed squares, grass remaining, completed turns, and action performed. Also, this scroll bar will allow you to scroll through the UI itself. We ended up making it kind of big because there's a lot of information, particularly if you look at the robot mower. We needed to be able to come up with a way to show you the direction of the mower ID itself, as well as keeping track of the energy units. And if a mower is on one of these little rectangles here, that means that they're on top of a charging platform. Here you'll notice that we have 5 different mowers in this scenario. If we go down here, there's actually 3 buttons to start with. So if you want to step through action by action, you can press next, and you'll notice when I press next, now the direction is just shifted west. If I keep doing that, the other 4 mowers also tend to do that for this particular scenario. And then you'll also see another significant improvement for our UI. We not only implemented LScan, but we also give you a visual representation of LScan in action. Let's do that again. And you'll notice that the first thing that this mower does on this scenario for number 1 is also highlight and does an LScan. If we wanted to study that, there's a 4th button that comes into play called back, and that just takes you back where you were. So the other nice feature is, if you don't want to keep pressing next for 80, 100 times, you can just press this fast forward button. Let's do that. And immediately, let's take a quick look at all the osmosis simulation summary metrics. And this will give you an idea that there were 79 squares mowed, and you've got the number of squares remaining, and even gives you the last action that was performed. Also, to meet requirements, we provided the simulation complete, where you can click on this, and actually it outputs a text file. And you'll also see the improvements of the LScan in action. In this case, the mower M0 had performed an LScan. But just like the individual implementation, there were also C-scans that were done as well. Like this discrete step, mower 0 did do a C-scan. The other nice feature about this application is, if you want to run another simulation, go ahead and load another scenario file. You can just by clicking this button, and then that's going to bring you back to this first screen that we started off with. And just to remind you, you are able to go into the team folder, and we've conveniently provided all of the scenario files that we were provided, and you just drag and drop those in. Anyway, thanks for watching. All right, so now that we've seen the application in action, this is a software architecture and design class where we really want to dive into the design modifications and team implementation to give you an idea of the architectural decisions that we made. A lot of work and collective thought went into this project. So first of all, we individually reviewed our class diagrams that we submitted for our individual implementation when we came together as a group a little bit over a month ago. So what you see here are 5 different class diagrams that represented what we thought was the best idea for the implementation requirements that we had previously. We also had to have a lot of conversations agreeing on what tech stack we were going to use and discussions about creating software contracts. And after we came up with a unified design, we wanted to implement that using an agile approach. And I think that proved successful on this particular project. So this represents the team collaboration unified architecture that we developed after a lot of discussion online and Google Hangouts, that kind of thing. So you'll notice that there are quite a few classes here. Many of them are the same as our individual implementation, but take close note. We've got a gopher class, lawn, simulation run, which is sort of a main engine of the UML design, as well as a mower class, mower communication exchange, which was a requirement for us to implement based on the team design requirements themselves. Mower optimal strategy was a new feature that we added, and that enabled us to be able to start thinking about how are we going to do a smart algorithmic structure that would enable these robot mowers to mow grass more efficiently. We also made use quite a bit of enumeration classes, specifically the strategy, action, directions, and content enumerations. So moving into team implementation, let's take a look at what we ended up doing and what you saw earlier in this presentation. So we worked with VirtualBox and we chose a Linux Mint installation to use as an operating system, and that ended up feeding into an environment that we showed you earlier that consisted of a REST-based backend that was Spring Boot, REST API, all of that developed in Java. So you can see how the class diagram is what we implemented into that backend approach. And then we had a couple really talented people work on the user interface front end. So we used React, and of course we used the Firefox browser so you could see something. And then we also included quite a bit of JavaScript for the lawn front end code, lawn controls, that kind of thing. Another perspective is taking a look at the tech stack deployment diagram, which is one of the diagrams that I'll show you in just a little bit in the design doc.pdf that we submitted. So that'll just show that you've got a classic client-server relationship going here where you have a web browser, an operating system, in this case Linux Mint, and then an execution environment where you have the React and JavaScript components. And then through HTTP, you've got a web server backend, and then you have an execution environment that is made up of things like Java components, Pojo, and Spring itself. Our design document, and I try to make this as organized as possible so it's really easy for you as reviewers to be able to go through and take a look at these artifacts that we spent quite a bit of time thinking about, which definitely helped us make a better application in the end. So you'll notice that we have the class model, which I already discussed, deployment diagram, and then I went ahead and grouped all the different sequence diagrams that we used together, as well as the component model, which you saw, and then the use case model. So if we go through these, here's our UML diagram, here's the deployment diagram, gives you an idea of what we did, and then hopefully you'll have an opportunity to take a look at these sequence diagrams, because I think capturing behaviors like executing mower actions, moving gophers, moving mowers, scanning squares, and starting the simulation really adds a lot of pizzazz and definition and architecture to what we actually deployed. Finally, we've also got a use case model that you can verify where you get to see the difference between the end user and the run simulation and all the interactions that went there as well. So let's get into the very last part of this demonstration, and that's just to talk about requirements. We ended up creating a spreadsheet to keep track of all the requirements that happened throughout all the different assignments that we had this semester, and we did a smart numbering strategy. So if we had an assignment 2 and had a requirement number like 19, then you'd have A219. We were able to use this to track all the different customer requirements. So we realized through this semester that it's not only about software architecture and design, but it's also about keeping track of